Hi guys, welcome to my new YouTube channel. I'm Shakira and today we'll be reviewing AP Statistics Unit 1. So, we'll be starting off with categorical data. What is a categorical variable? It takes on values that are in category names or group labels, basically anything that aren't like numbers. Examples are gender, eye color, yes or no questions, etc. Even if numbers are used, like zip codes, if they're used as a label, it's still categorical. So, how do we measure categorical data? One way is frequency, which are counts. So, how many people are in each category? For example, 10 students prefer math, 5 students prefer science, while relative frequency are percentages of the total. So, example, 67% of students prefer math, 33% of students prefer science. And we get these percentages by doing the amount of successes over the total times 100. For example, here the total is 10 plus 5, and then the amount of successes, so 10 students prefer math. So we do 10 over 15 times 100, which would give us 67%. Which is why we got the relative frequency for students that prefer math as 67%. So, tables used for categorical data. One of the tables are frequency tables, which show the number of individuals having each value. So we see for blue, there are 5 for blue, so the frequency would be 5, and so on and so on. For relative frequency, it shows us the proportion or the percent of individuals having each value. So it'd be a decimal or a percent, like we see here, which is basically what we did in the example before. And more tables used for categorical data are two-way tables, which summarizes the data between two categorical variables. So for example, if we're doing math and English and internal-external, both of those are labels. So we use a two-way table. Graphs used for categorical data. One of the graphs are bar graphs. Each category has a bar graph, and the height of the bar graph indicates the count or the percent, and it's best for comparing the categories. So we see period 1 represents 3 because that's the height, and so on and so on. Side-by-side bar graphs are used to compare two or more groups across the same category. So for here we see Boston, we want to compare multiple groups across that category of Boston. So a side-by-side graph would be best, and it's good to compare. More graphs can be segmented bar graphs, which show bars for each group, where each bar is divided into segments that represent the proportion or the percent of each category. So it's just the same thing basically, like blue would represent that the height represents that amount of percent of the total 100, if that makes sense. And a pie chart, which is essentially the same thing, but in a pie form, in a circle, it shows the percent out of the total. So it shows that toys is 14% of the total. And like for the segmented bar graph, we see oranges, which is about 52% of the data for all oranges. So 100 minus 52 would be the red part. So now we're moving on to quantitative data. Quantitative data takes on numerical values for a measured or counted quantity. So essentially, it's numbers now. So examples are height, weight, age, test scores, etc. And there are two types of quantitative data. One of them is discrete variables, which are counts, which take separate countable values, usually whole numbers. For example, number of siblings, number of pets. It's 0, 1, 2. You can't have half a pet or half a sibling. And there's continuous variables, which are often measurements, and they can be measured in intervals, and decimals are allowed. Like for example, it could be 5.6, 5.75 feet, etc., etc. Graphs used for quantitative data are dot plots, which displays individual data as dots above a number line. So for 2, we see there are 1, 2, 3, 4, 5. That's a frequency for having 2 numbers of brothers and sisters. And it's good because it shows the median and outliers and all the exact values. Stem and leaf plots show data by separating each value into a stem. The leading digit, which would be like 1, and then leaf. So if this is all our data sets, if they're all 2 digits, so we're taking the first value, that's the stem. So for 10, 12, 13, they all share the first value of 1. So that's our first stem. So what's the value after those? It's 0, 2, and 3. So that's it, 0, 2, and 3. So we continue that, 2 and 2, so we put that, and then we see 8 and 9. So it'll be 8 and 9. There's only 1, so the stem is 6, and the leaf is 7. 6, 7. And then that's just basically it. Graphs used for quantitative data. Histogram shows distribution using bars for intervals. Shows shape, center, and spread. So essentially, we see the interval from 20 to 10. Any value between 20 to 30 would be in that height, which it doesn't show each exact value, but it's good to see the shape and the center and the spread. And another graph are box plots, which summarize the distribution using the 5-number summary: the minimum, quartile 1, the median, quartile 3, and the maximum. And each part represents 25% of the data. So the minimum to the first quartile is 25%, quartile 1 to the median is 25%, and so on and so on. So, how do we describe a graph? We use SOCV, which is shape, outliers, center, variability, and of course, we always need context. Yeah. Okay, so for S, shape, it describes the shape of the data, obviously. So these are different ways we can describe the shape. Left skewed, I like to think of it if it's coming from the left, that's why it's left skewed. Right skewed is essentially the opposite. Symmetric unimodal is just uni, which is one height, like one increase. Uniform is when the whole thing seems constant. Binomial, which means bi, so there's 2 peaks, and etc., etc. O stands for outliers, which are unusual data points. Well, we can see here that there's data all the way to the far left, which is pretty unusual. Here we see the data all the way up here, that's pretty unusual, so essentially that's outliers. And there are multiple ways you can essentially
calculate whether to see if there are outliers or not.
One way is using the median and the quartile range, like the 5-number summary, which we can find the 5-number summary using calculators. The Number calculator, so if you want me to do a YouTube video about how to use the Number calculator, I got you. But for now, these are the formula, which is quite outside that range. It's an unusual data point. And then using means, that's the formula, mean plus 2 times the standard deviation. And you should only use this if it's normally distributed. So I recommend to often use the median instead, because even if it is normally distributed, at least like the mean and the median would be essentially like the same. So I would recommend using the IQR. C for center, which describes the middle, the center of the data. For mean, sum of all the data points divided by the total number of the data points. And that's a normal distribution, which often we use means to describe a normal distribution. Like if we're describing the center for a normal distribution, we use mean. The median formula, which is median is essentially the middle value. These are formulas you can also use to calculate them or just find the middle of it. And we usually use the median for a skewed data set, because I like to think of it as where the tail is, it stretches out the mean, so it's not really accurate. So that's why we have to use the middle value. B is for variability, which is the range, which is the max data value minus the minimum data value, which if there are outliers, range isn't the best to use, but IQR is. which is quartile 3 minus quartile 1, and it represents the middle 50% of the data. Standard deviation is also how it tells you how much the spread is, like from the mean, the average distance from the mean. And if it's a small standard deviation, that means most of the data points are close to the mean. But if it's a large standard deviation, it's the opposite, and most of the data points are far from the mean. Which formulas to calculate standard deviation are on the reference table, as well as the number calculator if you have the data points. Yeah. And also variance, variance is basically standard deviation squared. So, resistant to outliers. The median, the middle value, is resistant, although the range isn't. Like how I described, let's think of the range if it's 1 to 10. If we add 100, the middle value would still be like 5, 6, like around like 5. But if we did the range would be from 10 minus 1 to 100 minus 1, which is not resistant. IQR is resistant because the middle 50% would still be the same of the data. And standard deviation is not, because it's the average distance from the mean. If we add 100, the average distance increases by so much, so it's not resistant. Oh, and also mean. Yeah, mean is not resistant as well, because if it's 10, if the total amount of data is 10 over like 50, and then we add 100, so it's 110 over 50, the mean changes definitely. Normal distribution, which is essentially just, it's normally distributed, so it should make a bell curve shaped. And when we're drawing it, it should be n, mean, standard deviation, like formatted like that. And in the number calculator, all you need is the mean and standard deviation to produce a normal distribution. And empirical rule, which you should memorize, is the first standard deviation is 68% of the data. 2 standard deviation, 95% of the data. 3 is 99.7% of the data. Relative position. Percentile is the percent of data values less than or equal to a given score.
Example, if we went to the distributions and the mean was like 67 and the standard deviation was like 41, and we want to see every value that's equal to 100 and less. So every value equal to 100 and less, it would be around 79%, which is the percentile.
Standardized score is essentially, this is given on the reference table, I believe, which is the observed value minus the mean over the standard deviation. And the z-score, which tells us the number of standard deviations above or below the mean of the data value is, used when we know what the mean, we only use z-scores when we know what the mean value is. And that is a formula, which is also on the reference table. And now we'll be learning about linear transformations, which is a plus bx. And a represents the y-intercept and b represents the slope.
So, if we were to add or subtract from every value in the dataset, our center, the median, then the mean, it would increase or decrease by a. The spread, the IQR, the range, the standard deviation would stay constant. Q3 and Q1 quartiles, they would change by a as well, but Q3 minus Q1 would stay the same, thus IQR would stay the same. And the shape always stays constant. Multiplying or dividing from every value in the dataset, the center, the median, the mean, it would increase or decrease by a factor of b. The spread, the IQR, the range, the standard deviation would also increase or decrease by a factor of b. The shape always stays constant.
Discover, like,